Hi everyone, today we're going to be working on a wind audio system for our demo racing game. Let's go take a listen. Now what I've done is I've removed all of the car engine sounds so that we can just focus on the wind, and what you'll notice is the faster we go, the more aggressive the wind sound will be. And the first thing you're going to hear is an ambient wind sound that's just placed in the world just to give us that sense of, there's atmosphere around us. Now as I accelerate and go faster, you'll start to hear the wind get more aggressive. I think that's the most aggressive wind you can get. And as we slow down, this wind will go easier. Just about judge the braking distance there. Now here are the wind files that we have. We have wind 0, 1, 2 and 3, and essentially as it goes up the wind gets more aggressive, so I'll show you that now. It's a very light breeze. And then the most intense wind here, which sounds very blustery. If you'd like to create these sounds, I'll give you a quick example of how you can create them. What that is, it's basically the sound of Brownian noise which has been filtered with an EQ. So if I just play this one here, what it is, it's basically just a noise which has been filtered with EQ. And what we've also done is we've automated the gain up and down. So obviously wind isn't static, it gets more windy, it gets less windy. So you're automating the gains up and down to give it that sense of dynamic. Now the whipping sound you can hear if I go on the most intense one. So you can hear that sort of blustery, we'll say papery sound. What is that? It's essentially, it is literally paper. So what I'm doing is I'm basically wiggling paper in front of the microphone. I get that sound and then I'm applying distortion to it, and that's how you get that sort of whippy wind sound. And to me it sounds a little bit like if you're driving on the motorway and you can hear the wind going through the sort of the cracks of the vehicle, and you get that sort of sense of there's wind coming into the vehicle a little bit. That's what kind of that sound triggers in me. So it's more of a inside of the car sound. I think outside of the car you wouldn't have the blustery paper sound like that, but I do like the sound of it, so that's why I've got it there. Now if you don't have time to create your own sounds, what you can do is you can go to my website at sotasound.co.uk. You can go to the light version, which is completely for free, and that'll give you a limited amount of sounds, but it'll be enough to get you by all of the episodes that we'll be doing in this course. And then if you want all the sounds, every single sound that is in the racing game demo project, what you can do is you can get the full version for just £10. Now for the easy bit, what we're going to do is simply drag our lightest wind sound and put that into the world. I actually already have mine in here, it's over here, and that is simply going to serve as the ambient wind sound that exists in the world. Now this is the Metasound we're going to be working on. I want you to ignore this. This is just the lightest wind sound. This was just something I put in whilst I was testing. Now before we continue, I do want to do a quick note about this course and the way I've designed it. I've designed it in such a way that if you watch it from start to finish, essentially by the time you get to this is going to be really easy for you, because you will have already done the car engine audio system, and that Metasound is much crazier than this. And what you should notice if you have seen those episodes is you've probably seen this configuration before. We have the trigger inputs going into play, we have the trigger stop going into a trigger delay, which is tied to our custom crossfade time float input here, and then we have some crossfade logic over here. This should be very familiar to you if you've been following along. We've done this on numerous occasions, going into the mixer here, then the master gain, some bicut filters being processed here, and then straight out into the out left, out right. So the idea is, I'll go through this more thoroughly, but the idea is this should already be stuff you know. This should already be stuff that doesn't surprise you, and it should be fine to just sort of skip through it a little bit more. Now with that, let's actually go through it with a little bit more detail. Starting over here on the left, we have 3 wave players. Each of these wave players have loaded in the wind vehicle 01, 02 and 03 sounds. Each of these wave players are set to loop because obviously we want them to loop as long as we need the wind sound. Now this configuration over here you should be quite familiar with. Basically we're using a custom trigger input here to make the wave player play, and we're using a custom trigger input here which is then going into a trigger delay which is then going to stop it. We are setting the delay time and that trigger delay via this custom graph input here. This is a float graph input. This is called CF time. And you can see this is scattered all around the graph, and each of these will influence each other. One thing I do want to mention is that the play is going into the reset of the trigger delay. In the event that we are stopping the sound and this trigger delay is holding a stop, and then in the time that this trigger delay is still holding that stop, we fire off a play because we want to hear the wind sound. What could happen is the trigger delay could then release its stop and then prematurely stop the wave player. So the idea is we're feeding that wind 01 play trigger also into the reset, which gets rid of any trigger stops it may have been holding. Obviously these are all the same essentially, it's exactly the same setup, it's just the trigger inputs are changing their naming convention. So we'll move on here, we're going into the stereo mixer. Out of the stereo mixer we are controlling the gains here, and what we've essentially got is our crossfade and volume controls. Once again this should also look quite familiar to you. Basically we have an interp 2. At the top of this interp 2 we have this crossfade time, which you can see is over here as well. If you're wondering what this is, if you are just joining us, it's a float to time conversion. Then out of the target we're using a multiplier, and we're multiplying these two float graph inputs. We have this one which is called wind CF volume 1, which stands for our wind crossfade volume 1. Then we have wind vol 1. So this one is going to be being switched from 1 to 0 in the player control blueprints. 1 when we want to hear it, and obviously 0 when we don't want to hear it. Whereas this one is being set to basically anywhere where the volume sounds right. So what you'll notice is we have 3 wave players, and we are slowly turning down the volume on each of these wave players because essentially this one is louder than this one, and this one's somewhere in between the two. So we're just kind of balancing it a little bit because maybe this one was too loud, this one was too loud compared to this one, if that makes sense. So you can see we've went from 1 to 0.8 to 0.6, just balancing that volume a little bit. And then all of this is driving the gains essentially of this stereo mixer here. And then coming out of the stereo mixer we have a very simple setup here where we have another stereo mixer and then a custom graph input which is controlling the overall volume of it. Then what we have is the out left and out right being processed in stereo with 2 bi-quad filters, and we are using the cutoff frequency and the low shelf gain. So you can see that these bi-quad filters are set to a low shelf. Now let's take a look at what we're doing. Basically what we're doing is we have set this low shelf to 151 Hz, and we are taking away -9 decibels. So basically we're thinning out that sound a little bit. It was probably a little bit too muddy, a little bit too much low frequency energy taking up headroom. So that's essentially why we've done that. And then we're straight out into the out left, out right. We're now ready for our player controlled blueprints. Now this is the wind vehicle audio system, you can see it here, but before we do that the first thing we need is a reference to the Metasound we've just created, because if we don't have a reference we can't actually communicate with that Metasound. Now I've already added mine. If I type in MS sound effects wind, you can see here, and I can just drag that out and get access to it there, and then from there I can speak to it and tell it what I need it to do. Now if you haven't got that, what you need to do is you need to actually go and select that in the content drawer, and then from there it's very easy to add by clicking on the little audio icon here. Now the way this wind vehicle audio system works is it's essentially looking at the vehicle's speed. When the vehicle is going slow it's going to play the less aggressive wind sound, and when the vehicle is going fast it's going to start playing the more aggressive wind sounds. So with that in mind, what we needed to do is we needed to use something that is checking every frame. So obviously that would be the event tick. To keep our code separate from game logic, what we've done is we've used a custom event here, which we've named wind vehicle audio, and we are calling that custom event from the event tick using a call function. So if I look for wind vehicle audio, there it is. So you simply type in, we've done this a few times now, call function, and you can see these are all of the custom events that have been created. So that's what's happening there. Event tick, we've got our wind vehicle audio as a call function. If I double click on this, it will take me over to my custom events and we can start to go through the code. Now this custom event is firing off execution pulses every frame into this branch. And what we're basically checking is how fast is the vehicle moving. If it's moving very fast, we want a more aggressive wind sound. If it's going quite slow, we want a less aggressive wind sound. So what we're doing is we're getting the vehicle movement components, we're getting the forward speed into a multiplier, and then we're using the is miles per hour boolean, which should already be there in the starter contents, going into a select float, and this is essentially converting this these units into miles per hour or kilometers per hour based on whether this variable is true or false. And then that's being fed into the branch. Now if you're wondering where this is, you can just create it yourself, but you can also just copy and paste it if you're using the starter contents. So if you're using the starter content, if you go up to your event tick in your sports car pawn, you should be able to find something like this, and then you can just copy that and drag it down to the wind vehicle audio system. Now once we've checked the speed of the car and we're going through these branches, we're checking, are we less than 80, or are we less than 120, or are we less than 160? Going out of each of these, we're going into a sequence, and then from this sequence we're then going into a do once, and then also resetting the do once below or above. So you can see if I go to a middle one, in this sequence we're resetting the one above and also the one below. This one, there is no one above, so it's just doing the one below. So out of the sequence we're going into a do once, because it is an event tick. We don't need to tell our Metasound again and again and again to, for instance, stop. We don't need to tell it to stop every single frame, do we? So that's why we're using the do once, because we only need to fire one execution through now, once we've checked essentially the speed. So now with that in mind, we have references to our sound effects wind, Metasound sound effects wind. We have 3 execution triggers, and on all of these execution triggers, we are writing in wind 0 1 stop, 0 2 stop, and 0 3 stop. This is referring to these here, and it's basically just firing off and telling all these wave players to stop, because essentially we're going so slow. What we want to do is we want to let the ambient wind take over, so this little speaker here can be our wind essentially. Now once we got those to stop, what we also are doing is we're setting the crossfade vol 1, 2 and 3 to 0. So that's taking each of these and setting them all to 0 essentially. So we've stopped them and we've also brought the volume down to 0. Now from here, it's simply a case of copying and pasting all of these lines across like this. You can see they're all exactly the same. And then what you want to do is write in the functionality that you want. So for instance, we are not less than 80, we're going to go false, but we are less than 120, we come through here. I don't want to stop this wind 0 1, I want to play this wind 0 1. So instead of writing in wind 0 1 stop, we've written in wind 0 1 play. These two remain stop, these two remain 0, but this one has to become 1, because now we want to set this graph input here from 0 to 1, because we now want to hear it. And then as we go faster again, you can see wind 0 1 play now becomes wind 0 1 stop, and now it's wind 0 2 play, and now it's on wind crossfade vol 2, that goes from 0 to 1. This one gets set back to 0. And as you may have guessed, now it's Win 0 free play here. And on the third one, this is now set to 1 so that we can hear it. And these two are set to 0. So that's the functionality. It should all work perfectly fine for you now. Let's go test it out. So you can hear the ambient wind sound. As I accelerate now, you'll start to hear the wind go more aggressive. And then it'll go to the second level. And then if I go into third gear now, it'll go into the third level. Because we're now quicker than what we defined inside of the branch. And then it'll come back down. And then when we come to a halt, you can hear just the ambient wind taking hold. So there it is, it's all working perfectly fine. Thank you very much for watching. I'll catch you next time.